Alrighty, today we are learning about piece functions. They can also be called piecewise functions. If you see either of those two terms, know that we are talking about the same kind of function. We're going to define and evaluate these functions, as well as learn to graph these functions and identify their domain and range. So let's start with evaluating. Here is our piece function because it is giving you pieces of functions over certain intervals. Those intervals are the x values less than 1. That's where our first piece is graphed. And our second piece is x values greater than or equal to 1. And that is going to be the equation 2 to the x power. So we're going to start by evaluating our function at 0. To do so, we need to select the piece from which x equaling 0 is a solution. If you look at the first piece, we're told that the x values are to be less than 1, and 0 is less than 1. Therefore, we only will evaluate for that piece. So we plug in and simplify, and that is going to give us our function at 0 equaling 1. And that's it. Let's look at our function for the value 3 when x is 3. Well, if we were to try and use that first piece again, 3 less than 1, that's not true. That's not a solution. So we need to look to the second piece of our function where x values are greater than or equal to 1. 3 is in fact greater than or equal to 1. So we plug into the second piece, 2 to the third power, and simplify. That gives us our function at 3 is equal to 8. All right, so that is evaluating. Now let's try graphing. To graph this function, the first thing we need to do is identify the two pieces of our domains. And this is how I have found it to be most easy, I guess. I will designate x values less than 1 with red, and I have shaded that section on my graph in red so that the piece of the graph that is to be less than 1 is made clear to me. And the second piece of our graph I have denoted in blue. So what I'm going to do is I'm only going to graph my red function, which is negative 3x plus 1. I am only going to graph that function in the red area, and I am only going to graph my blue function, which is x minus 1, in the blue area. So let's start with the red function, why don't we? It is a linear equation. So we identify our slope and our y-intercept. Our y-intercept is 1, so we begin at our b value, and then we will move according to our slope, which means we will go down 3 and to the right 1. And you'll notice that we're on that dividing line. But for my red function, I am not to include x values that are equal to 1, so I just leave it as an open circle. And then I'm able to create my lines graph. Now notice it is only in the red section because that equation is only to be graphed where x is less than 1. And we can see that that has been done. Now let's graph our second equation. Here we have our b value. It's also linear, so our b value where we begin is at negative 1. Okay, now I know that we are in the red section right now and we're trying to graph the blue equation, but I will show you what we have to do in just a moment to correct that. So we begin there, and then we're going to move with a slope of positive 1 over 1. And there would be my next point if I move up 1 over 1. My blue function, I am allowed to let x values be 1. And that is where I have plotted that second point. I can go ahead and plot yet another point to help me create a nice straight line. And there is my line. Now notice my line is only in the blue section. I did not trace all the way back to my y-intercept because that is in the red section. I'm actually going to totally omit that point. I'm going to go and erase it because it is part of my blue function and it's not to be in the red area. But I needed that point to be able to identify my y-intercept. So you could plot that point or just kind of barely just put your pencil there, but then move it so that you know where to begin and then how to move. The last step is to verify that what we have is in fact a function because we're calling these piece functions. And if you use your vertical line test, you'll find that it is a function even at 1 when x is 1 because there is only one point that satisfies the function at 1. The other point is a hole, which means we are not including that point. So, ladies and gents, that is it for graphing piece functions. Stay tuned. I will be posting more of these. I will talk to you later. Thanks.